data migration, ETL, and ML healthcare use case on Snowflake in AWS with Sparkflows. First, we'll start by going over some issues that plague legacy data platforms, chiefly a lack of scalability, the cost of data movement, integration with services, and a lack of collaboration. Each of these issues leads to a lower return on investment and delays in time to market. From a healthcare perspective, this means a lack of visibility into patient data, additional complexity when integrating newer forms of patient data, and weaker enforcement of fraud detection technology. This leads to rising costs in healthcare, ultimately pricing out potential customers. For this example use case, we will focus on detecting and identifying fraudulent claims. We will start by extracting our claims, transactions, and providers' data from multiple sources and then loading them into Snowflake. We will then perform exploratory data analysis, cleanse the data, and perform data quality checks, then transform and load our final dataset into a Snowflake warehouse, where we will then perform machine learning on the data stored in Snowflake. From there, we can create dynamic reports and experiments using analytical apps on Sparkflows. And finally, we will be able to perform quick predictions using AutoML. By using Sparkflows, we can effectively and quickly solve this use case using only a single platform. Sparkflows is a cloud-ready data and machine learning platform that provides self-service, low-code workflow builders. Sparkflows will allow any user to turn their data into actionable insights in the most efficient way possible, leading to true, complete solutions. In this video, we're going to go over an example of claims data processing, or fraud detection, on Sparkflows, hosted on AWS. First here, we have the project homepage. This is where we can see our workflows, executions, and datasets. We can also see the machine here in our AWS dashboard. We can see that we can view the health and metrics of the Sparkflows service and how it's running. Now let's get into the workflows. The first workflow we want to cover is our data migration workflow. This is where we will be bringing in data from various sources into Sparkflows and then writing to a Snowflake warehouse. We can do all of this using workflows in Sparkflows. We don't need to use any other tools or any other services. We can also accomplish this using workflows with no code. We can extract the healthcare data from different sources, transform the data, and join the data before writing to Snowflake Warehouse, all within a single workflow. First, we will be reading our claims data from our HDFS, or our local storage on the machine. Next, we will be reading our transactions data from a Hive database. We can also browse our Hive database directly from the Sparkflows UI. Next, we will be reading our provider information from a MySQL server. Now we can get into cleaning our data and transforming our data. First, we will be dropping some columns and we will be renaming some other columns. We can also do data quality checks such as flagging outliers here from the nodes themselves. We can also filter out data which does not meet our requirements. We can also transform our data, such as extracting new features from our date and time fields. All of this can be accomplished using no-code and low-code nodes with simple dropdowns. We can also do more complex processes, such as SQL joins, also using no-code. We can also do data cleaning processes such as imputing with constants, removing null values from our columns, or dropping duplicate rows. Finally, we will be selecting the columns that we need and writing to Snowflake. Here we have a Snowflake connection, and we can specify all the necessary details, starting with our Snowflake warehouses. Next, we will select our Snowflake databases, our Snowflake schema, and finally our Snowflake tables, all of which can be browsed from the UI itself. Next, we'll be looking at our Data Browser tab. This is where we can view all of the connections and data sources which we have access to from the Sparkflows machine itself. Starting with our Snowflake connection, we can see all of the databases and all of our schemas that we have in one single place. Next, we'll take a look at our Hive database connection. Here we can see our tables along with the claims transactions which we pulled into our workflow earlier. And finally, our HDFS, or the storage local to the machine. Here in this workflow, we are now reading from our Snowflake databases, and now we are conducting our analysis directly on the data, which has now been compiled into a single, more usable data set, all using Snowflake. This makes it easy to conduct analysis, as now any user on this Sparkflows machine can pull from the Snowflake database. Next, we'll talk about pipelines. Pipelines are a way for us to execute workflows or other functions in order. Pipelines give us the ability to select in which order and multiple workflows are to be run in a row. We also have access to EMR functions, where we can add steps, create job flows, or EMR workflows. In this case, we are using the EMR. Here we are looking at our Spark logs being read from S3. Here we can view the app name, when the job was started, completed, its duration, and the user that requested it. In this case, the app name is our workflow name. We can also view this information directly from our Sparkflows machine in the Executions tab, where we can see the name of the workflow that was executed along with the results of the execution. If we go to the Results tab, we can then see all of the visualizations and the output of the nodes. Now let's take a look at our data analytics. In this analytics workflow, we are first reading from Snowflake, where we have created a space for all of our claims data to be in one place. Next, let's take a look at a pipeline. A pipeline allows us to schedule and to coordinate different workflows together in one place. We also have access to EMR jobs or EMR nodes. In the pipeline editor, we can also look at schedules. This allows us to regularly run our workflows in an orderly fashion. We can also view the executions of the pipelines from the pipelines page. Now that we have completed our workflows and have our data sets, we can move on to other parts of our project. Specifically, we will be taking a look at how we can share our project with other users on the Sparkflows machine. First, we select a group, and then we can save the permissions. Now other users on the machine can look at our project and the work that we have done. Now that we have completed this portion of the project, we also need proper version control. To do this, we can connect our Sparkflows machine with a GitHub connection. We can push our projects to Git along with a commit message, or we can also import projects from Git directly. By selecting our repo, our branch, and then our root folder, we can bring in projects that we have created in the past or projects that are currently being updated. We can also export our project to a file. Now let's take a look at how we can model our data in Sparkflows. Here we are trying to create a k-means clustering model to cluster together our healthcare claims models to better be able to find patterns for fraud. We are using a k-means model using SparkML. Here we can configure the model using no code. After we have created the model, it appears in the Models tab, where we can find a model summary with all of its parameters, along with its training metrics. To make our project more usable to others who may be less technical in nature, we can also create analytical applications. This allows us to create an extremely flexible UI directly in Sparkflows so that users such as business users can then interact with the work that we have done and run the workflows without having to edit them themselves. Here in the workflow editor, we can find the workflow, the project, and we can edit the stages of the analytical app directly. Everything is using a drag and drop system, which is extremely intuitive and easy to use, allowing any user to make their work available to others. Now we're going to take a look at how we can train a classification model to find fraud in our healthcare claims dataset using AutoML. To use AutoML, we simply need to select our dataset, and then we can configure our target column, in this case our fraud flag. On the right, we can also find and explore the schema of the dataset that we selected. Then we need to save the model to a path. Now let's take a look at an execution which we have run before on the same dataset to create a classification model. Here we can see all of the AutoML configuration that we have done. To configure the model, you only need to select the algorithms that you want to include in your feature columns. Here in the executions, we can find all of the runs that we have run using the AutoML configuration. In this case, in our leaderboard, we have one gradient boosted classification model. Below that, we can find the hyperparameters, along with if we click on the model details, which will show us the exact details of that specific execution and model. To the right of the model, we can also find our model metrics.